Before we begin, I would like to apologize in advance for any possible background noise. Fact is, I was traveling today and wasn't able to reach home before the session starts, so I had to do emergency landing and do a quick setup. So it's not my soundproof home, but hopefully there will not be too many interruptions. Before we start, of course, thanks to our helping us organize that and this and have opportunity to hang out for these 2 days. Okay, so next session is DevOps, return of the security, and we will be discussing security and the DevOps processes. So, few words about myself. My name is Mustafa Toroman. I work as a solution architect at the company Authority Partners. I've been working with mainly U.S. enterprise companies for the last 5 years, working a lot on security things and basically implementing these kind of things like DevOps processes and cloud adoption in enterprise raises a lot of security questions. So this is why this session in the first place. Also, here's my Twitter handle. If you feel free that I can assist you in any way, feel free to reach out. I always try to answer the question or at least point you in the direction of someone who might actually do it. I've been Microsoft Azure MVP for the last 5 years, also very certified in Microsoft technologies, over 50 Microsoft certificates, Microsoft certified trainer for, I don't know, almost 10 years, and so on. But let's cut to the chase and discuss the real topic here. So, DevOps and security. DevOps is basically here. It's we can with almost certain 100% say that this is not a trend. This is not something that like IT people like imagined and just like want to play cool. DevOps is here and it's been in IT industry for over a decade now. A lot of companies are driving a DevOps adoption, trying to improve themselves. And how does the DevOps process look like? So basically, the cycle, the never-ending cycle of DevOps starts with the planning. We plan what we want to do in the next period of time, then we create it, we verify that it's running properly, we package it, we release it, potentially do some configuration in the production environments and any other environments. And once the product, the application is released, we monitor. We see what's going on, are there any potential issues, and based on everything that happened in the last cycle, based on monitoring and any of the challenges through other processes, we start the cycle again with the planning. We plan to adjust to potential issues, to any bugs, crashes in the production, and so on. And based on that, we create a new plan to address possible issues, and then and plan for the new things, new features that we want to implement, and start the process all over again. Now, basically, the big thing about DevOps is that it's driving business. That's why the adoption of DevOps is so good in the first place. What happens is that organizations realize that they get up to 20% improvements in time to market. So their time to reach the customer is 20% better. Software quality is better because we are trying to automate all steps possible, trying to eliminate possibility of human error, and then by doing that, providing better software quality. Frequency of deployment is much better because we are not limited to releases per cycle or per quarter or per year and so on. We are increasing revenue, and customer reach and retention is better because all these steps, like we are providing better value to the customers, and then based on that, we are getting better retention and better customer reach. There are a lot of definitions on DevOps, what DevOps is, and how to approach it. There's no silver bullet on how to adopt DevOps inside your organization. But one thing that I really like as a definition of DevOps is definition by Donovan Brown of Microsoft that says DevOps is providing value to our end customer. So basically, it's not a single thing. It's about any tools necessary to provide value to your end customer, to your end users, and that's the bottom of it. Okay, so how the complete DevOps solution look like? We start with the coding. From our devices, from our personal computers, laptops, whatever you're using. And basically, once we code that, we need to commit the code to the repository. Once the code is inside the repository, we set up certain rules, certain flow, how the code completes, how we complete merges, pull requests, and so on. But basically, once the code is in the repository, it needs to be built, it needs to be deployed, it needs to be tested. Potentially with cloud, we have opportunity to easily do some additional user beta testing. And then once we have the product in production, we can monitor and analyze what's going on. And based on that, start the circle again. So basically, it's again about the circle, like the never-ending circle of DevOps. It's continuous thing that's going on. And basically, and there are like different things on how we can organize that circle, but basically it's plan, code, build, test, release, deploy, operate, monitor. Now, one very important thing is that we need to remember that about monitoring and setting things like how we monitor the application is not about performance and availability anymore. So when we discuss monitoring with the traditional enterprise, or mainly any operations that do application monitoring, two main factors were performance and availability. So how much CPU, how much RAM are you using, is the application up or down? Those were main things. Like the only thing that in the past monitoring was considered with. Now we are expanding the monitoring part with a lot of other metrics. We want to know about potential HTTP errors. We want to know about user metrics, like what is the flow for the user to get from one page to another? What is the, for example, if we are developing a new feature, a new cool feature that we invested a lot of time in, we are betting on it that it's going to be a game changer for us. And once we deploy it, we realize that users are actually not using it. Now, this kind of monitoring and user metrics can provide us additional information about, like, are users at all interested in that? Like, if they are just tried and never return to it, it's something that we need to cross from our list and say, okay, let's move on. People are not interested in this. This was a wrong bet. Let's not waste any more time on that. Or maybe just people are not aware of it, maybe hidden it inside the page or inside the submenu, and people are not even aware of the new cool feature. So we need to address things and like analyze what's going on, and based on that, more extended monitoring than when we create a plan. But on all of this, people are often forgetting about one thing, like security. And I've seen a lot of discussion between people, especially people in security, that are mainly concerned with the security. Is this DevSecOps or SecDevOps or how we call it? To be honest, in my personal opinion, it's neither. It's just DevOps. DevOps is basically this process, this culture that is evolving around software development, around traditional software development lifecycle. DevOps is much, much more than just dev and just ops, because people are usually like trying to associate that with dev and ops. And the initial idea about bringing the dev and ops was behind the DevOps, to have two sides that are traditionally confronted, to have them work together and provide more value to our end users by resolving issues faster, by considering all of the angles together before it's like too late, and all the other things that traditional DevOps brought. But the truth is, security should be inside this cycle. Security should be essential part of what's going on and should be basically very close to what's going on with the DevOps and software development from very beginning. Now, what are we talking about? There needs to be a clear and consistent communication. Like all parties involved should be aware of all the aspects and all the plans that are going on. Now, this is where the DevOps started. Like when we say DevOps, it basically contains of the two words, development and operations. Now we're trying to squeeze in security in there, and it's about bringing all three parties, so development, operations, and security people, to bring them to work together, to be aware of all challenges throughout the process. The traditional IT organization that doesn't implement DevOps would have issue where developments are just coding, trying to create something, then just throwing that whatever they develop to operations that need to figure out what is in there in the first place, on where should I run this, like what are the requirements, and so on. So there's a issue of million different problems, and same thing goes with the security. We need to include the security in this discussion so we can plan properly. Like from the development's perspective, what are our requirements? Like what technology are we going to use? What are our requirements on the infrastructure that is needed? On the other side, infrastructure needs to be aware of the all software requirements. What are the options for the maintenance? What are their challenges? So they might help resolve some of those challenges to infrastructure support. In the mix, security is often forgotten, so we need security people to discuss application security, information security, what's going on with our database, how are we logging an application, are there any vulnerabilities, are we vulnerable to SQL injection or cross-site scripting, and so on. Second part is that we need to observe security as a code. And many people often translate infrastructure as a code to security as a code. This is true to some extent, but not completely. Like infrastructure as a code has a lot of little things that can help with security in the first place. So infrastructure as a code is a pretty cool tool to enforce security, but it's not the only aspect. The truth is, when we say security as a code, we need to basically consider everything that is code. So that starts basically with application code itself. So with the original repository where our application is coded, like stored. So it starts there. Then we can translate further to other things, like we can then discuss infrastructure as a code, configuration as a code as well, and all those components should be considered and observed as security as a code together. Next thing that we really need to consider is mandatory training. Everyone on board should be trained to know at least basic concept of security. This goes to both development, both operation, and security people that traditionally do those trainings. But everyone needs to be aware of basic concepts on how to do secure trainings, how to address certain security issues, how to respond to security threats. People need to be aware of those things about these security processes, and we need to do mandatory trainings on that. This is often forgotten to be continuous job. Basically, we need to do things constantly. Why? New people join our teams all the time, so we need to train them on certain topics as well. Also, things in IT change rapidly, especially when we are considering cybersecurity today. It's constantly evolving. There are billions of dollars involved in cybersecurity right now. The threats are constant, and it's constantly changing. Like every day we have something new, we have some new 0-day vulnerability and so on. So we need to continuously train our people, and we need to integrate security inside the DevOps cycle. It's not like what happens a lot, I would say most of the time even, that security is considered when everything is done. Like we have this DevOps process, we are doing planning, we are doing everything, we deploy the application, and once application is out there, it's already in the production, then security people are involved, that they like do some testing and see what's going on to give their insight. And in a lot of situations, that might be too late. So the idea is to have security integrated in the DevOps process from very, very beginning. Now, big problem with the clear, consistent communication is, in the first place, that we have to have three sides involved. Like in initial challenge of the DevOps was to have development and operations talking to each other, to have a continuous communication to discuss everything together. Now we're throwing in the third party, and everyone needs to be involved in every communication. We need to remember that. Like every discussion that is made inside the DevOps cycle needs to involve everyone on the team. So basically, development, operation, and security should be included in all the discussions that are going on. It's not enough that security is discussing with the development something, or that security is discussing something with the operations, if one of the side is not aware of the conversation. So something that was discussed between security and the development, operation might not be aware of, and just might made a mistake that is in conflict with what was agreed in a different meeting, and so on. So how do we address these issues? How do we address clear and concise communication? Well, basically, one of the problems in the cycle is the numbers. So let's look at the numbers shortly. We have traditionally, when we are discussing software development, most of the personnel are going to be developers. Now, studies show that if you have a group of 100 developers, most of the organization, on average, will have around 10 people in the operation on the operation side. 10 people that are responsible for the infrastructure, build, release, basically the operation side of the story. Now, where the numbers are starting to be very troublesome is the security. On these 110 people in software development environment, only one person will be assigned to security side of the thing. So only one person. So to begin with, this is a real bottleneck. Security is becoming bottleneck because when we have 110 people, or just say over 100 people creating something, excuse me, and only one person available to discuss the security side of the story with all 100 of them, that's becoming an issue, because this person has less than 5 minutes per day to discuss with everyone everything that's going on. So that's becoming a bottleneck. First thing that we need to do is expand our security personnel, or at least have people in the operations and development side to be included in the security as well, so that at least our architects or team leads are becoming more familiar with the security and can take off the plate something that, for the people that are dedicated only to the security. Okay, so next things are tools that can help us get there. So do a mandatory training, because awareness begins at day zero. We need to have a cross-discipline training. I already mentioned that, but we need to repeat it. Everyone on board needs to be aware of everyone. So this is like a training that involves all the parties. Both development and operation need to be aware of those security issues and specific problems that are concern of only certain teams. Okay, basically, as I said, we can't know everything. It's impossible, especially in like IT is ever evolving. It's impossible to know everything. This is like one of the things I'm really like annoyed by is when say people say they want DevOps engineer and then have a list of things that they want to do. Like in my personal opinion, DevOps engineer doesn't exist. Like 9 out of 10 times when I discuss with someone that are performing role of a DevOps engineer is that they are system engineer with the background of a system engineer, basically that it's into cloud now and they know how to write scripts. So basically that's describing the operation side of the story, and they are basically ops engineers, not DevOps engineers in the first place. Because the word DevOps engineers kind of implies that someone knows everything. They code, they maintain infrastructure, they know networking, they know operating systems, they know basically everything in IT. It's not possible. With everything going on today, it's not possible. So it's not possible for a single person on the team to know everything, but at least everyone can know basics. At least everyone can know what is the bare minimum to get the job done. And then from that point, someone can pick it up and continue discussing it on a bit higher level. Okay, effective communication starts also with the tools. A big no are Excel lists and Word templates. First of all, they are an issue from the security point of view because they can be malicious to start with. Someone can throw certain macro in it or whatever, and then that can start a whole chain of issues inside our team. Second problem is when we are using these kind of documents, it's really hard to keep track of what is going on. It's really hard to track who has the latest version, who sent the last version of the document. When I try to update something, am I working really on the last version or just something I have on my desktop or whatever? So it's hard to keep track of the changes and knowing what is really going on. And often this is throwing us off our game, and we are missing steps that are already agreed because simply someone skipped a version of 2 of document and we lost a couple of things that were kind of planned. What we want to use is basically boards. We want boards like, for example, what you have in Azure DevOps, where we have a backlog, where we have a plan, something that is accessible to everyone and basically updatable and changeable on go. Whenever I update any of the items or anything that is in there, everyone will be aware of that change because it will reflect the view everyone has. Another thing is that we want to use is Git or versioning, that we know what's going on. Basically, we can track all the changes. This is like where I like to say why infrastructure needs to be observed as a code, because then we can track the changes of the infrastructure the same way we are actually tracking the code changes. So let's start with this part, security as a code. As I said, security as a code is not only infrastructure as a code. It starts with the application source code. We need to treat that safely. We need to see how things are done. Through basically any cloud environment, it doesn't really matter what we're talking about, supports certain version of infrastructure as a code. We have in Azure, we have ARM templates. AWS has CloudFormation. We have also options to use Azure CLI or Azure PowerShell. There are Terraform option there. So we can do many different things on how can we address infrastructure as a code. Now, one very important part of the infrastructure as a code is how it can help us get there, how it can help us increase the security. First thing is that basically we need to do, when we do infrastructure as a code, we are addressing things like we are using versioning, we know how the code changes are done, what's going on, and so on. So basically, it helps us maintain information on how infrastructure might change. It also helps us maintain all the environments in the same condition, because this is one of the big problems in software development, where you have like, I don't know, dev, QA, UAT, production environments, and often someone will just go in there and like make a change in dev and deploy something to dev and it's not working, and then tweak something in dev and then it works. Then we deploy that something to QA and it doesn't work because there's some little tweak in the dev environment that wasn't addressed. Like infrastructure as a code helps us maintain that workflow, knowing if something was done in dev environment, something in the environment changed to have our application work, we need to address that change across the environment. Second part of infrastructure as a code with a security perspective is that we are not treating our infrastructure as a pet anymore. Like I come from that background where like I was the enterprise admin and no one had access to certain servers. Like I was the only person that could access certain servers, and there was no way in hell that developer is gonna come to my production environment and install something manually. That was just not permitted. I was taking care of that server. They were my servers. I was maintaining them. That is like treating your infrastructure as a pet. You're in big trouble if something happens there. You will spend hours, maybe days, to figure out what's going on. With infrastructure as a code, for example, if there's a breach in your environment, sometimes someone gained access to your production servers, it's really easy to address that issue because you can just run down that environment. You can completely destroy it and build it from scratch in the matter of minutes, because you're using infrastructure as a code to deploy a completely new environment that will replace your production environment in a matter of minutes. So that kind of like a breach can be just overrun. Like someone is in our servers, just destroy the servers, create new ones. We will just replace the sensitive information, username, password that might get compromised, and we're good to go. So that's really easy way to go. Another thing is that we need also to use configuration as code. We have multiple tools for that as well, like Chef, Puppet, desired state configuration, so on. So basically, this is helping us to, after building our infrastructure as a code, to throw any custom configuration that we might need for our application to work. So this is also another part of the story. And everything from the source code, infrastructure as a code, configuration of the code, everything needs to be treated with certain security as a code aspect. And finally, what we really need to address is secret management. I already mentioned secrets when we discussed like our production is compromised. Like that is a way to deal with the secret, because using secret management, we could do a secret rotation and just like rotate the secrets for, like, we can have multiple secret options and just rotate them for each deployment. So basically, if someone gains access, they will not be able to use those for a long time at least. Now, the second part of the secret management is how we treat sensitive information like usernames, passwords, connection strings, and so on. There are really cool tools on how we can actually do that for the secret management. For example, when we are building new virtual machine for our deployment, and one of the things that we need to provide there are admin user and admin password. Now, if we're doing infrastructure as a code, we can probably we need to provide that in the script. If you're going to run the script, information like admin username and admin password should be available there. Keeping them in a plain text in a repository is a really bad idea. Why? There are multiple problems and multiple incidents over the last few years when people from big companies accidentally pushed to the public repo something that shouldn't be there, like sensitive information, connection strings, those kind of information. And to avoid that, we can basically use different things we can use different things like For example, in Azure, we have Key Vault, where we can, in the script, just reference where the information is stored in the Key Vault, and then just pick it up from there without ever exposing that information in a plain text. So that's another option as well. Okay, so now let's look at this DevOps cycle. From security perspective, how can we throw in security in each of those steps? What can we actually do to include security in each of the steps that are in the DevOps cycle? So we need to include security in the planning. We need to add security to sprint planning and reviews to address certain issues, to set up minimum security requirements for certain things. Like for each of the, I don't know, if you are doing like new user story, we need to address, like, we need to set up minimum security requirements that we need to follow up. Like some basic, I don't know, API testing, like who is available, how can we run this API, does it require authorization, and so on. So basic security testing should be included in each of the user stories that we do. And we need to include security as early in the process as possible, from the very beginning, because I mentioned that before, security is often included too late. And then when they do a review, it's really hard to fix certain things because they are done in a really wrong way. They are affecting multiple things. So it often means that we need to start from scratch for certain parts of the application. So it's not really convenient to include them too late. When it comes to coding, we need to do trainings to our people. We need to make them aware of secure coding best practices. All the development that we are doing should be test-driven development. Like this is something that DevOps culture drives really forward. Like everything should be test-driven, because if we want to automate as much of the steps as possible, we have to have as many tests in place as possible to verify that whatever we did is good and that it can go directly to production. We need everyone to use correct tools. We need everyone to use the same tools. One of the big problems in traditional software development without DevOps is that people are using different tools, different processes, different methodologies, and this is like creating a lot of issues. We also need to set up proper pull request structure on how we verify the pull request is correct, valid. It has a quality that should be included in there. We need to run tests. We need to include peer review to complete the code reviews for our team members. We can also set up build processes to verify that pull request is valid and run certain tests before pull request is completed and merged to higher instance of the branch. When we're talking about builds, we need to do code analysis. Now, people here often kind of confuse that there are two parts of like static code analysis and dynamic code analysis. People just usually say we need to do code analysis. Where is the difference? Basically, static code analysis are run against the code when it's in the state of being in the repo, basically just going through the code and trying to analyze what's going on and if there are any kind of vulnerabilities, known vulnerabilities, plain open mistakes in coding, using compromised libraries, and so on. What happens in the dynamic code analysis, that code is analyzed in the state of running after it's been compiled. So basically, that's the difference. Like static code analysis analyze code, dynamic code analysis analyze code after it was compiled in the state of running, how the code is going to behave once it's actually running. We also need to perform dependencies check. If certain part of the application API that we're building has certain dependencies. We need to verify what's going on. Our connections that we're making to those dependencies are secure, so on. We need to also address package management. Are we using the latest versions of different libraries? Is there known vulnerabilities to libraries that we're using, and so on? So that needs to be addressed in the build process as well. When it comes to testing, we need to develop security test cases. As I said, these need to be included early on in the user stories themselves. We need to set up how we are going to like observe the security, how we are going to verify that everything that is done has that security component in there, like what is the authorization on executing something, how can I gain access to this or that, can we verify that someone unauthorized cannot reach this destination or access that data, and so on. Then we have, from the testing perspective, we have fuzzing. Fuzzing is basically just throwing random values at your application, trying to throw it off. People often confuse fuzzing and load testing, because load testing is just throwing a bunch of stuff at your application, but it's just trying to throw as many requests as possible and see how the application will behave. Now, the thing is that load testing is basically also concerned with the performance testing, but it is concerned with the security as well, because during load testing we want to see when like application A is stretching to its maximum, are there any holes? Like when there's high usage, is there certain ways to bypass certain endpoints, certain authorizations, encryptions, or whatever? So basically, load testing from the security perspective is a time when we are trying to see, is application vulnerable when things are not going perfectly well. Fuzzing is kind of a same thing, a similar thing, basically, that is trying to throw as many requests to application, but at the same time, it's trying to throw random values. Like if I try to like during the login, it requires like, I don't know, so username and password, and if I just try to provide unexpected values there, if the application is going to like get confused and let me in, and things like that. If I try throwing random values, am I going to provoke unexpected response? Also, what we have is DAST and RS. Basically, another thing that is really and often confused, two testing methods that are often confused. First one is dynamic application security testing. Second one is interactive application security testing. They often get confused. Dynamic application security testing is also known as black box testing. What happens in the black box testing is basically trying to break into the application without knowing what the code is. I just know like public endpoints to my application, and I just want to like try to get in without proper authorization or whatever. I don't have correct credentials to access, but I'm going to try to access anything. So basically, dynamic application security testing or black box testing is trying to break into our application without knowing what's going on in the background. Interactive application security testing is trying to analyze your code, like try to analyze all dependencies and everything what's going on, and then trying to break it down. Basically, we are observing all the possible endpoints, not only the ones that are public, but also in the background. Like once I'm the application, can I bypass certain things and get to the places I shouldn't be in, and that sort of thing. So basically, it's analyzing code, seeing what code does, and then trying to bypass it. Also, this method is also known as a white box testing. Okay, once we release and deploy our application, we need to do certain things there as well. We need to do post-deployment security scans. We need to see if everything is in order, just to have a security baseline that needs to be in place, and just verify that it's already there. And also, we want to do a deployment checkouts that everything went in order, that there are no unexpected changes, or if the changes are there, that they are predicted and something we anticipated before the deployment happened. Also, once the application is there, we need to operate and monitor. So we need to have monitoring logs to analyze what's going on. We need to occasionally rescan for vulnerabilities. So basically, things are happening all the time. So if our libraries and vulnerabilities were not present today, this might be the 0 day, and we need to address them immediately. So rescan for vulnerabilities at least daily. Track dependencies is something on our dependencies that is being compromised, so on. We need to address patching, especially if you're using infrastructure as a service, virtual machines. We need to do regular patching and updates on our servers. We need to perform pen testing. Now, pen testing is something that people would like to do more often, but from the financial perspective, is not really justified. A lot of organizations I work with kind of agree to do pen testing once per quarter or once every 6 months. Ideally, it would be good to have pen testing once per like, I don't know, whatever cycle you're doing, like once per sprint or whatever, but it's not always possible. So you might want to try to get to quarterly pen testing. We want summer reviews of critical tasks to keep tracks. This is where boards come in. We want to know what are our main tasks and what we need to address. We do need to do assurance scans just to see that everything is in order, nothing that we're not anticipating. Role-based access control activity. When someone is accessing, why we need to analyze who is accessing production environments and why they are doing it, because that shouldn't be something done frequently. Security metrics strength and activity needs to be in place. It's perfect to have different dashboards to monitor for any anomaly and so on. And possibly we can do runbooks for auto healing. For example, we can set up, if we detect DDoS, we can set up out runbooks to block the access from certain IP addresses, or similar thing. If we are getting brute force, we can just like eliminate those addresses. Once they detected, they can like be automatically blocked without even any interaction from our side. Few things that we want to include as well. Access management. Definitely want to like know who's having access to which environment, how they're using it, why they're using it. We want to have just-in-time access and just enough administration approach included there as well. So no one has access unless they don't really need it, and no one has access by default. They need like to elevate their privileges to actually use that. We need to address data security as well. We need to see what's going on with our data, how it's like data should be encrypted at all times. Encrypted at rest, encrypted in transition, make sure that everything is in place. We want to do network security scanning just to verify that we don't have any kind of anomalies, listeners, unauthorized accesses inside our network. And something that is often forgot with the cloud is basically eliminated, but a lot of organizations are still running their own data centers on-prem, and we need to address physical security as well. Like, who really has physical access to our servers, who can access our server room, and so on. As I mentioned, like with the cloud, this is basically eliminated. We have top-of-the-art security setup, but it's something that we want to address if you're still running on-prem. Okay, thank you for your time. I hope you enjoyed the lesson and learned a few new things that might help you down the road. Once again, thank you for attending this day. Have a good rest of the day. Bye.